Hello everyone, welcome to Driven Math and Physics. We're looking at another problem on electricity, and this one is specifically on power and energy transfer. The resistors X, Y, and Z are placed in a metal container with 400 grams of water. The resistors convert electrical energy to heat. The system is run for 8 minutes and the temperature of water increases by 12 degrees Celsius. Given the specific heat capacity of water and also no heat loss to the surrounding. Now, there's something that is missing here that we're going to talk about. I think this is something that I missed when formulating this problem. So let us dive into this. Now, the first thing they want you to do is to calculate the total energy transferred to the water. So that will be Q, giving us MC delta T. Okay, so we actually know the mass that we're dealing with here. And the mass is simply 400 grams. But I think I would prefer for us to, let me see, the specific heat, delta T. Okay, we can work in grams. So that will be 400 grams multiplied by 4.2 joules per gram degree Celsius multiplied by the delta T is actually 12 degrees Celsius. So when you multiply everything, it's 400 multiplied by 4.2 multiplied by 12. That will give us 2160 joules. So this right here is the heat energy transferred to the water. Okay, and they want you to find as well from here the total power supplied by the resistors. Now, energy is equal to power times time. All right, but do we know that power is equal to energy over time, or Q over time? So we know the Q, it is 2160 joules divided by time, which is 8 minutes, but in seconds that will end up becoming times 60, that's seconds. And then when we do the calculation, it will end up becoming 2160 divided by the multiplication of 8 times 60. It gives us 42 watts. This right here is the power. Now, what I wanted to talk about that time, and I was saying there's something missing, is this one. It says calculate the current drawn from the power supply. And so what we're not given is the voltage from the supply. So let's assume that the voltage from the supply is the same as the previous question, which was 20 volts. Okay, this is the case, and they want us to find current drawn. It means now, given the power, which is 42 watts, and given the voltage, we can calculate current. So current, remember, power is equal to voltage times current. This leads us to say current is equal to power over voltage. That will be 42 watts divided by 20 volts. This should give us something that makes sense. That will be 2.1 amperes. Okay, so we're given the current drawn from the power supply. Now from here they want us to find the equivalent resistance. Okay, so this is getting interesting. So equivalent resistance, we're going to use the same mechanism. We'll say power is equal to I squared R. Okay, so equivalent resistance is total resistance. Can we make that as a subject? That will be power divided by I squared equals R. So R will be equal to, so the power, remember, is 42 watts divided by 2.1 amperes squared. That will give us, okay, so let's try to calculate that. That will be 42 divided by the square of 2.1. That will give us 9.523 ohms. That is the total resistance of this circuit. Now from there they want us to find, can you suggest one way of increasing the heating rate of water using the same resistors? Okay, so I think one of the ways is simply to increase power source or voltage supply. Okay, this will also increase the heating rate of the heater that we're talking about, of this system, and also you can try to reduce heat loss. Okay, if you reduce energy losses, that will also be helpful. That means you need to use insulation, better insulation. That will also help you reduce heat losses, and that will help with the heating, right? So that's what we're going to look at today, and that is all. Please compare with your solutions and tell me what you think in the comment section. Like and subscribe to the channel. Thank you.